Welcome back. Today we are going to discuss an epichemistry question. The link to this question has been given in the description of the video. The question is, how many electrons are transferred in the reaction represented by the balanced equation above? This is the balanced equation and these are the four answer choices. I will suggest you to pause the video and try to solve the problem by yourself. Hope by now you already have solved this. Let us just now discuss it together. So the question says that this is a balanced equation. Let us just quickly verify it in terms of atoms first. So we have 2 manganese here, 4 times 2, 8 oxygen here, 8 oxygen here, 10 bromine, 5 times 2, 10 bromine here, 16 hydrogen, 8 times 2, 16 hydrogen. Now let us check it in terms of charge. So we have 2 negative charge here, 10 negative charge here, and 16 positive charge here. So we have a net, we have a total of 12 negative charge and 16 positive charge. So what is the net charge here on the left hand side? It's a 4 positive, right? 16 minus 12 is 4. Now here you have 2 plus and 2 of this. So this is 4 plus as well. So in terms of charge also, this is a balanced equation. Now from this balanced equation, we cannot figure out just in a single step that how many electrons have been transferred. So in order to do that, I just want to show you how to balance redox reactions. So this is balancing redox reactions. The link has been included in the video description. So though we are not going to balance the redox reaction, but we will use the steps that have been used here in order to find the number of electrons that have been transferred. So the method used to balance the redox reaction is called the half equation method. In this method, the equation is separated into 2 equations, one for oxidation and one for reduction. And you really do not need to know at this step which one is what. That can be figured out later. And then each equation is balanced by adjusting coefficients and adding water, proton and electron in this order. First, balance elements in equation other than oxygen and hydrogen. Next, balance the oxygen atoms by adding the appropriate number of water molecules to the opposite side of the equation. Next, balance the hydrogen atoms by adding proton or H plus ions to the opposite side of the equation. Next, add up the charges on each side. Make them equal by adding enough electrons. Next, the electrons on each side must be equal. If they are not equal, they must be multiplied by appropriate integers to be made the same. Next, the half equations are added together, cancelling out the electrons to form one balanced equation. Common terms should also be cancelled out. So we will take the help of some of these steps in order to find the number of electrons that have been transferred in this equation or in this reaction. So let me just write this down in terms of half equation method. So we will divide it. So let me just first write the manganese part. So while doing that, we will not touch the oxygen, the oxygen and hydrogen atom part. So we will not touch the proton and the water part. So this is getting transferred to 2Mn2+. So this is one reaction. What is the other reaction? The other reaction is 10Br minus is getting converted to 5Br2. As I said or mentioned earlier, that you really do not need to know that which half equation is oxidation and which one is the reduction. But as an epichemistry student, I think it's not difficult to figure it out. Let us just do it. So in case of this, you have, I'm not considering this 10 coefficient. If I only consider the bromine part, I have one negative charge here and this is in the neutral state. So it is 0. So it's going from -1, right, to 0. So there is an increase in oxidation number of +1. So increase in oxidation number means this is an oxidation reaction. Let us check here. Now, how to find this? If we assume that the charge on manganese is X, then how we can do it? So the oxygen atom carries a total -2. 4 of them is present, so it will be a -8. So if the manganese is having X and we have 8 from oxygen, what is the total charge of this species? Without considering the coefficient, of course, only this part, manganate, -1. So this is how actually you find the oxidation number. Then X becomes +7. So we can say that the +7 is the oxidation number here And here we can see, without considering the coefficient, positive 2 is the charge or the oxidation number. So there is a decrease of 5 units from +7 to +2. So the reduction in oxidation number means this is a reduction reaction. Though you do not really need to know, but anyway you can figure it out. So there are two half equations. One is the reduction, one is the oxidation. Now let us just balance it in order to get the balanced equation as mentioned in the question, and in doing so we will get to know how many electrons have been transferred. So first let me write down 2 MnO4 negative. It becomes 2 Mn2 plus. So the rule says that for each oxygen atom you will have to add one water molecule on the opposite side. Let us just count how many oxygen we have. 2 times 4 is 8. So what we will have to do, we will have to add 8 water molecules on the product side. Now we will have to balance the hydrogen by adding the protons on the opposite side. How many hydrogen we have? 8 times 2 is 16. So we are adding 16 proton here, right? Now the next is, after you balance the oxygen and the hydrogen, now you balance the charges. We will have to see that we have same charges on each side. If not, we will have to add or the subtract electrons. Now how many charge we have here? 2 negative, and this is 16 positive. So what is the net charge? 16 minus 2 is 14. So we have 14 plus charge here. How many charge we have here? We have 4 plus, right? Because water is neutral. So there is a surplus of 14 minus 4, 10 positive charge here, right? So always the positive charges are balanced by adding electrons. On which side? On this side. So if I add 10 electrons here, so that 10 electrons will balance this 10 surplus positive charges, and the reaction will be balanced in terms of charges or electrons. So that's it for this half reaction. And for the next one, we do not really have any oxygen or hydrogen, so this is really very straightforward. And the bromine is also balanced 10, and here 5 times 2 is 10. But now we will have to balance the charge. So how many negative charge we have here? 10, right? 10 negative charge, and this is 0 because bromine is in the neutral state. So in order to balance the charges, there is a surplus of 10 negative charge here. So we'll have to add 10 electrons on the opposite side. So we are going to add 10 electrons on the opposite side, and that makes it balanced in terms of charge. Now the next step was, if you do not have the same number of electrons, you will have to multiply one of the equation by a coefficient to make the number of electrons to be the same. But in our case, if you look carefully, we have 10 electrons in this half reaction, the reduction reaction, and also 10 electrons in the oxidation reaction. So that step is not necessary. So we know there has been a transfer of 10 electrons. Now let me just do the final step, that is adding them up and showing that we get the same balanced equation as has been given in the question. Let us do it. So I am doing it in red because these are all mixed number. So 10 electron, so all the thing on the left hand side is getting added on the left hand side, and all the things on the right hand side is getting added on the right hand side. Okay, then what is the next rule? We will have to cancel. We'll have to cancel the electrons if they're the same, and they have to be the same. And anything, if there is anything common, we will have to cancel them as well. But here there is nothing else. That's it. So we got back to the original equation, which is the balanced equation. Let me just write it once. So we have 2 MnO4 minus plus 16 H plus plus 10 Br minus equals 2 Mn2 plus 5 Br2 plus 8 water. So look at this carefully. So this is the same reaction, and there has to be the same because this is the ultimately the balanced reaction that you get after balancing this two half reaction, which are reduction and oxidation, by balancing the electrons. So in doing this process, we came to know that there has been a transfer of, let me just circle this, 10 electrons. Okay, so that is our answer. Let us just look at the answer choice. A says B, so it's not. A says 2, it's not. B says 5, it's not. C says 8, it's not. And D says 10, yes, it's 10 electrons. So we can just say that D is the correct answer. 10 electrons are transferred in the reaction represented by the balanced equation here. Thank you all for watching my video. Please hit the like button and subscribe to my YouTube channel, Circle Research and Education. Here I post videos on test prep math question from PSAT, SAT and SAT math. I post AP chemistry and AP biology question and dashboard analysis. See you all in my next video. Som Okone. Happy learning.